Now, I will explain about the abstract. Coagulation and flocculation are the important process that needed in wastewater treatment. In the current study, the purpose of this experiment is to identify the effectiveness of new generation of coagulant reagents compared to the common coagulant reagent. The aluminum sulfate, which is known as the alum, will be used as a common coagulant reagent, while the polyaluminium chloride and also the polyaluminium silicate will be used as a new generation of the coagulant reagent. This experiment also specifies about the application of new generation of coagulant reagents. Results show that the percentage removal by using aluminium-based coagulant, the highest percentage removal is by using a polyaluminium silicate coagulant with coagulant dosage of 300 mg per liter. Thus, this new generation have potential efficiency to remove colloids or particles in wastewater.
Assalamualaikum and hi. Now we go to the introduction. In this modern era, high technology and cities were developed, but unfortunately, this is also leading to more disadvantages, especially to water. Industrial waste causes water source to be polluted. Groundwater and surface water both are contaminated by dissolved and suspended particles. These particles vary considerably in source, composition charge, density, particle size, and shape. Malaysia also facing few problems regarding water, which are lacking clean water source, water pollution, urban flood disaster, and environmental degradation around river. Coagulation and flocculation wastewater treatment included in wastewater treatment plant. Coagulation and flocculation in water treatment are used to remove suspended solid through a process that destabilizes the suspended particle in water. Coagulation chemical which charge opposite those of the suspended solids are added to the water to neutralize the negative charge on non-settable solids. Once the charge is neutralized, the small suspended particles are capable of sticking together. Flocculation, a gentle mixing stage, increases the particle size from such microscopic microfloc to visible suspended particles. Microfloc are from a high molecular weight polymer. Color coagulation aids may be added to help bridge, bind, and straighten the floc and weight and increase set influent and effluent. There is a difference between influent and effluent. Effluent is the wastewater or other liquid, partially or completely treated, flowing from reservoir, basin, treatment process or treatment plant. Influent is the wastewater or other liquid flowing into reservoir, basin or treatment plant without any treatment. Aluminum sulfate is approximate in result of evaporation of water. In the process result in dry product. This alum is mixed with sulfuric acid and water and then heat gradually to boiling. It is also allowed for some time and clear solution is yielded. Therefore, these researchers aim to apply coagulation and flocculation method to treat water and wastewater. In addition, providing an overall description and explanation of coagulation and flocculation process.
Now, I will go to the methodology. Aluminium sulfate is the most widely used metal coagulant for water treatment during the past decade. It is manufactured from the reaction of bauxite ores with sulfuric acid. Its formula is approximated in result of evaporation of water in the process result in a dry product. This alum mixed with sulfuric acid and water and then heated gradually to boiling. This is purpose to allow some time and clear position is yielded. For the polyaluminium chloride, which is known as the new generation of coagulant reagents, top priority is related to the different aluminium species distribution in the polymerized solution. The pre-polymerization is involved for controlling up to the certain extent to aforementioned reaction purpose. And then for the polyaluminium silicate chloride, this coagulant is evaluated for treatment of contaminated tap water. It also prepared for polymerization technique or the composite polymerization. Specifically, the presence of silica change into structure of polyaluminium chloride increase the molecular weight of the coagulants component that can lead to the enhanced aggregating power and bigger, denser floc formation.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohon bin Abu Kafar. My matrix number is AA221925. So for result in this, I will be presenting results and discussion. We are researching or focusing on the most effective and the least effective coagulants that can be used in the coagulation flocculation process for wastewater treatment. So there are a few examples or a few coagulants which we tested in this research. For example, which is polyaluminium chloride (PaCl), polyaluminium silicate chloride (PaSiC), and aluminum sulfate (alum), which is widely used for coagulation and flocculation process, which we knew every time we have to do coagulation flocculation process, we will use alum. So that's why we are researching about other coagulants that have potential to be better than alum. So if we see from this table, some of coagulants are being compared to alum, which is PaSiC and PaCl. So from the table we can see that PaCl and PaSiC is a better coagulant than alum itself. This is because at 100 milligram per liter of dosage, alum only has a 7 to 72% of turbidity removal, while PaCl and PaSiC both have 88% and 90% of turbidity removal. It is also for COD removal, as we can see at 300 milligrams per liter of dosage. Alum only has 61% of COD removal, when PaCl has a 60% of COD removal and 77% for PaSiC. Next, we will see the second table, which is the the coagulants that are polymers based, which is PaCl and PaCPE. So for this PaCl, this PaCl is particularly was made in the laboratory. So from the table we can see that there is a significant difference between PaCPE, PaCl and alum itself, because at only 6 milligrams per liter of dosage, PaCl that was made in lab has a 97% of turbidity removal, and PaCPE has a 99% of turbidity removal. So that's why PaCl and PaCPE is much better than alum. That's all for results and discussion.
The basic idea is to add different additives to a pre-polymerized coagulant structure in order to create a homogeneous stable product with a higher molecular weight and better coagulation flocculation performance than the original reagent. The difficulty lies in achieving the desired balance between increased efficiency and cost effectiveness, which are fundamental requirements for the creation of new products. The application of two techniques, namely introducing polymerized silica in the pre-polymerized metal solution or introducing polymerized silica in the metal solution, followed by polymerization, has been the focus of research on the incorporation of silica within the pre-polymerized metal solutions, aiming to produce products with a larger molecular weight.